Welcome. Today's lesson is 6.4. We are jumping to chapter 6, which seems strange, but if you recall, yesterday's lesson was on inverse trig functions. 6.4 is also inverse trig functions, but it includes a little bit of right triangle trigonometry, which should actually completely be review from geometry, and you did it in Algebra 2 as well. So we should be able to breeze through this, kind of a nice light day. So I'm going to start you off with just kind of a warm-up. If you can visualize this question, sometimes visualizing the picture is the hardest part, not necessarily for this one. But a 96-foot tree casts a shadow that's 120 feet long. What is the angle of the elevation of the sun? If you aren't familiar with angle of elevation, that would be from where you would be standing looking up to the sun. That creates the angle of elevation. So this red arrow is your angle of elevation. Okay, so knowing that you have a 96-foot tree, so I know my tree is 96 feet tall, and it's casting a 120-foot shadow. So the sun would be up here again, so my shadow is down here. Angle of elevation is labeled there with theta. So just making sure you have all your parts in the correct spots, and then it should be pretty easy to see. Because this is a right, we can assume this is a right angle because the tree is standing straight up. From my theta, I know the opposite side, 96, and I know the adjacent side of 120. I don't know the hypotenuse, but I don't need it because SOHCAHTOA tells me that tangent is opposite over adjacent. So if I set up a ratio here, I could say tangent of theta equals opposite 96 over adjacent 120. And then on your calculator, I'll show you my 84 here. Above your sine, cosine, tangent keys, if you didn't already see in blue, so if I do second tangent, that will bring up the inverse key for you. So I'm going to do inverse tangent of my ratio, side ratios here, and that will tell me my angle. I should also include, this is clearly, you want to be in degree mode. So you will have to go to your mode on your calculator, make sure you're in degrees. All of any triangular trigonometry is degrees. We don't, well, you can use radians, but for this one we won't, because it would probably make more sense to people to say, hey, you're looking up at an angle of 38 degrees rather than the radian equivalency. All right, moving on then. You are going to be asked to find all the angles between 0 and 180 degrees that satisfy the equation sine of theta equals 3/5. So again, you're in degrees because you're between 0 and 180. So if you think about where is the sine equal to, well, 3/5 is like a 0.6. So you could kind of guess and check based on your unit circle knowledge, or pick up your calculator and do inverse sine of 3/5, right? So inverse sine of 3/5 gives you the angle of 36.9. So I'm just going to round that to 37 degrees if I visualize that on my circle here. Okay. Well, all of the angles between 0 and 180, so that's anything in quadrants 1 or 2. Well, if this, remember sine is y. So if this y value right here, I mean, I could draw that in if I wanted to approach this as a triangle. This sine value right here is going to be the same in the first quadrant as it is over here in the second quadrant. So there's another angle. If I visualize, right, again, this y, sine distance here and here are equivalent. So if you visualize that, knowing this is 37 degrees, if I reference my 37 degrees into the second quadrant over here, then the red angle, of course, that's what we're trying to find, that angle is going to be 180 minus 37, which is 143 degrees. So my answers then, I have two answers. They're 37 degrees and 147, or 143, excuse me. So my first quadrant and my second quadrant angle. And you can verify these on your calculator, right? Like just go back to the original question, type in the two angles that you got. So I did sine of 37, sine of 143. For both of those, I got 0.6. Basically, I had rounded, of course. So 0.6 is 3/5. So you will know if you got it right. All right, you give this one a shot. So maybe pause the video and try this one. Okay, so same question, find all the angles between 0 and 180. So make sure you're in degree mode. Where is the tangent? What angle has a tangent of -12? So when you type in inverse tangent of -12 on your calculator, of course, your calculator follows the inverse restriction rules. So it's going to give you the angle in the fourth quadrant. And that's -85 degrees. Well, that clearly is not between 0 and 180. So knowing this angle right here has a tangent ratio of -12, then in the first quadrant, I have to figure out where that symmetrically is going to have a tangent value of -12. Well, in the first quadrant, the tangent's positive, so that's not going to happen. So if you take your -85 degree angle and swing that into quadrant 2, right? Again, a reference angle. So I took the -85 here and put it into quadrant 2. Then the blue angle from 0, you always start at the positive x-axis, to the terminating side here, that's 95 degrees. And you can do the math if you need to. 180 minus that 85 is 95. So between 0 and 180, that is my only angle that has a tangent value of -12. All right, 2 more left. These are very correlated to the work you did yesterday, but not on a unit circle. Okay, so you will be asked to evaluate tangent of inverse sine of 1/5. Okay, so what is this really asking? And well, it's saying, first of all, evaluate where is the sine equal to 1/5. So I have to do the parentheses first. And whatever I get from here, I'm going to find the tangent then of that angle. So obviously 1/5 ratio, that's not on your unit circle. So I'm going to visualize this on a triangle. Well, inverse sine, if you, again, think of SOHCAHTOA, right? Inverse sine is opposite over hypotenuse. So if I go over to my triangle, if this is my angle, then opposite would be here, 1. Hypotenuse would be there, 5, right? 1/5, 1/5. Use the Pythagorean theorem, so a squared plus b squared equals c squared. And if you solve that for b, subtract 1, square root 24, and you will get 2 square root of 6. Okay, and that's a little quick, but I'm assuming you can recall the Pythagorean theorem. So now that I have my triangle kind of drawn based on my inverse sine, I can say, okay, well, I know that the inverse sine of 1/5 equals theta. That's this triangle represents this. Now I can go to the tangent, work my way out, and I can say, well, I'm going to do the tangent of the theta then, because this is theta, right? So tangent of theta, if I come back to my triangle, tangent, you know, tangent is opposite over adjacent. So from theta, I would go opposite over adjacent. So I'm going to do 1/2 square root of 6. And then you need to rationalize that denominator. So multiply the top and the bottom by the square root of 6, and you'll get square root of 6/12. All right, you pause the video and give this one a shot. All right, so starting at the innermost, inverse tangent of x. So I'm going to draw a triangle, and I know inverse tangent, SOHCAHTOA, is opposite over adjacent. So from my triangle, from theta, I will go opposite is x, adjacent is 1, because this right here is x over 1, opposite over adjacent. Using Pythagorean theorem, a squared plus b squared, well, that's 1 plus x squared, equals c squared, and then I would square root that, right? So 1 plus x squared, I can type that out for you, equals c squared, in case you didn't follow that. So if I use the Pythagorean theorem and then square root both sides, I get the hypotenuse. So now that's my triangle here represents the inverse tangent of x. Now I can work my way out to sine of theta. Okay, so I go back to the triangle and I find the sine. Well, again, you know, sine from SOHCAHTOA is opposite over hypotenuse. So from theta, I go opposite, which is x, over hypotenuse, which is square root of x squared plus 1. You can't have a radical in the denominator, so multiply the top and the bottom by this whole radical. And so your denominator will just be x squared plus 1, and your numerator you can just leave as the quantity of x times square root of x squared plus 1. And that would be your final answer. And there you have it. Enjoy your day.